Hey folks, welcome back to this AI weekly paper series. Unfortunately, this week I didn't come across anything fun that I wanted to report on. However, um, Gemma 2, which is an open Google model, came out, and they did some interesting things in their pre-training, which I thought might was worth talking about. So here's the Hugging Face blog on Gemma 2. And so this came out 27th June. And if you look at the original Gemma announcement, Gemma 1, which came in end of Feb. So fast progress between the two models. And what these guys did is to release a 9 billion model and a 27 billion parameter model. And both of them looks like have been pre-trained on a context length of 8K, which is good. The other interesting thing is the Gemma 2 models were trained on twice as much data, and it looks like they were trained on 13 trillion tokens for the 27B version and 8 trillion for the 9B version. So, and because it's all closed source, like even though the model weights are available, the training details are never released by these big companies, so we don't know. So we don't know what's the training mix, which is very unfortunate. So now let's talk about the interesting things in Gemma 2. So a couple of things that they did, or rather 4 things that they did, is use a sliding window attention. So what sliding window attention means that instead of have each token looking at all the tokens before it, it only looks at the tokens before it in a limited window. So what I mean by that is if we look at this attention matrix, each token will only look at the tokens that are before it in a window of size 3. So here, the can only look at the word to and went and not the word Sam. So that's what sliding window is. I believe even Mistral models had sliding window attention, and it's more efficient because you're not computing n squared attention matrices. So that's one thing. The other thing is that the attention logits, what they do is they will cap the logits to prevent them from growing excessively. So what they do is rescale the logits. So this is before the softmax has been applied. So this is just the normalized product of query times key. And what they do is they have a soft cap defined, and they make sure that they rescale the logits to be in this range. And so they say, I guess this benefits because this prevents the logits from growing super large. Other than that, I'm not sure like what's the real benefit here. This for sure could make things a bit more stable for training. Yeah, but other than that, I'm not sure. They did release a technical report, which is actually pretty nice because they did a bunch of ablation studies as well. And oh, I see that they have a 2.6 billion parameter model as well, which is interesting. So let's look at the logit soft capping section. Okay, so I guess it comes from Gemini 1.5. So, okay, so we ran ablations on model generation with and without attention, and found that across most pre-training and post-training evals, the quality of generation is minimally impacted. So is it really useful? I'm not sure. I don't know. So let's see if they have any ablation on that. Doesn't look like it. So yeah, the jury's still out on how useful this is. The other thing is they do knowledge distillation. You have a teacher and student model kind of paradigm. And an interesting thing that they did was they had an ablation, like just to check how, if you trained a model from scratch versus you trained a model using a distilled model, you trained a model using the distillation paradigm, the distillation works better. So that's I think that's kind of known at this point. So yeah, that's pretty much it. So yeah, so they used this 2.6 billion parameter model trained over 500 billion tokens. So either from scratch or from distillation. So that's an interesting data point, but nothing surprising. Finally, what they did was they used model merge methods. Now, this Hugging Face blog talks about a lot of methods. However, when I go to the paper and I search for model merge, I don't see anything. So if I now just search for merge, I don't see anything. So I'm not sure where they were doing model merging, but in general, what model merge is, so there are a lot of different techniques for model merge, but if you train a bunch of different models on the same data set, different data sets for different tasks, you can merge the weights by taking some sort of smart averaging across all the parameters. And that tends to work pretty well and has been demonstrated in these techniques, which are, the techniques are both super simple, like just taking a simple average or taking some spherical averages to task related averages and so on. But the whole idea is that you have a bunch of models and then you somehow combine the weights together. The key here is that architecture remains the same. So now here it says that they use the warp technique, which warp technique is typically used in the RLHF phase. So if I go here in the RLHF, oh, well, here's model merge, but no details. Wow. And it says we average models from experimental runs with different hyperparameters. So it seems like it's a standard model merge, and it looks like they refer to this warp paper. Which I haven't looked in the details of it, but it looks like it is averaging different policies together. It trains multiple policies and then it tends to average them together. But overall, Gemma seems to be doing pretty well. It gets competitively close to Llama 3, despite being 2.5 times the size or smaller, despite being 2.5 times smaller. And yeah, even the 8 billion parameter variant is pretty good across the tasks. And then, they have like, how do they prompt the model for chat-based interactions? What are the chat tokens and so on? And Hugging Face usage. So I think this is pretty straightforward, but yeah, I thought I might share this. Every week it looks like we have new models, so but hopefully you learn something new with the 4 different techniques. All right, I think that's all I have for this week. Thanks for watching.